A very good evening to my chemistry lecturer, Puan Nur Husna binti Abu Bakar. Today we are here to the presentation which is entitled the production of olefin in petrochemicals, and we specifically choose ethylene to be our olefin and to show how it produces. So let me introduce my group member. Me itself, Devendra, son of Sia Subramanian, with matrix number of 33 DPE 20F1022, and Tilageshwaran, son of Mohana Sundaram, with matrix number of 33 DPE 20F1033. So let us move on to the topic. So basically, what is olefin? Olefins are unsaturated hydrocarbon. It is because the carbon to carbon double bonds, so it is called as unsaturated hydrocarbon. And specifically ethylene is known as a king of petrochemicals, and olefins, which is also can be ethylene, is more reactive than paraffins, which is alkane. So and olefins are also inexpensive compound to get, and steam and ethylene can be produced by two ways, which is steam and catalytic cracking. And the most common ways that most of the industries are using is steam, due to its compatibility. So the basic formula for the ethylene is C2H4. So how ethylene or ethene was produced? Less amount of ethylene will be produced through natural process to obtain petroleum. So this defines us that when we getting the petroleum, the portion of the ethylene is very less. So ethylene has a versatile use in petrochemical industry. So what they do is they obtain more ethylene by cracking long chain hydrocarbons in fractions in petroleum. So this is what we are going to present now. There are two types of cracking, as I've mentioned just now, which is catalytic cracking and steam cracking, and I will be explaining about catalytic cracking, and my teammate will be explaining about steam cracking. So basically, what is catalytic cracking of ethylene? A process where a long chain of hydrocarbons are broken down into shorter chains. So basically, a long chain of hydrocarbons will be inserted into a distillation column, or into a furnace, into a reactor. It can be either anything, and the feedstock can be anything. It can be a naphtha, it can be a ethane, propane, it can be anything, but as long as it is a long chain hydrocarbon, which will be put into the catalytic cracker. And this is the catalytic cracker, catalytic cracker is specifically a thing which is used in the distillation column. So a long chain hydrocarbon is inserted to the catalytic cracker, which is inside the distillation column. And inside the catalytic cracker there is a thing which is known as catalyst, and this catalyst name is aluminosilicate, and it is also known as zeolites. And what does this zeolite does is, when the long chain of hydrocarbons are inserted into the catalytic cracker, the catalyst has a larger total surface area. Thus, the long chain hydrocarbons will get attached to the zeolite, and it will basically break down the carbon to carbon bonds between the long chain hydrocarbon, and it will produce the products that we needed, which is ethylene. And there will be any byproducts such as hydrogen or methane, or it can be anything, depends on what type of long chain hydrocarbons we are inserting. The criteria for this reaction to occur is catalyst. We need to have the presence of catalyst, which is aluminosilicate, and the temperature need to be 500 degrees Celsius, which is much lesser than the steam cracking. And the pressure need to be atmospheric pressure, which is basically 101.3 kilopascal. Let me show you the structure of a zeolite. So this is how basically a zeolite looks like. So the zeolites can be modified preferably as how we wanted the product to be. So that's a specialty of the zeolite, and that's why it is widely used in petrochemical industries. And basically this will be the diagram for the catalytic cracking. It can be either steam cracking, it can be either a furnace, reactor, or distillation column. So when the naphtha is entered to the furnace, it is being heated up, and it will be going to the quench unit, and there will be a compressor. It will compress the long chain hydrocarbons, which will be in the form of gas. And after that, in the distillation column, which is known as a separator, there will be the catalytic cracker, which is inserted in it. When this long chain of hydrocarbons are compressed and getting into it in the high pressure, it will be undergo some processes, and it will be and the outcome will be propylene, ethylene, and hydrogen, and the byproducts will be hydrogen. We can get ethylene and propylene because we have used naphtha as a feedstock. That's all about my presentation. The rest will be presented by my friend Tilagesh. Since then, thank you.
Good morning, madam. My name is Tilageshwaran and I am from DPE 2B. My number matrix is 33 DPE 20F1033. As Devendra has did his presentation until catalytic cracking, I am going to continue my presentation from steam cracking. For the production of ethylene, we will only get the little amount of ethylene via the process to obtain the petroleum. So it might need other inventive way to produce more ethylene, because it has wide usages for the production of plastics and for some chemical substances which can be used for further production of other products. So there are two other ways to produce ethylene from the long chain hydrocarbons, which are the catalytic cracking, and another thing is steam cracking. So right now I'm going to discuss and present about the steam cracking. In steam cracking, the only difference between the steam cracking and catalytic cracking is the steam cracking will use the high temperature compared to catalytic cracking, where the catalytic cracking it uses the temperature until 500 degrees Celsius, but in steam cracking it will use until 900 degrees Celsius, and at the same time it won't use that much of catalyst. So yeah, that's it. So after that, it is used under very high temperature. As I said earlier, it is difficult to control the end products. This is one of its disadvantages in steam cracking, because we are using it in high temperature, and alkenes are completely decomposed to smaller alkenes and hydrogen. So let us see the flow of the steam cracking. The feedstock which is used in this process is ethane and propane. We can also use butane, which these things all are classified as long chain hydrocarbons. The first process that we undergo is cracking and quenching. After that, after it get cracked, it is moved to the compressor, where it get compressed and it is get dried. After that, it will go for the separation process for the separation of the product that we need, and also the byproduct, where the byproduct can be used for other production of another product, or it get expelled for some reasons like have no usages. So the final product that we will get is the ethylene and byproducts. So let me continue in another slide. So let us see the diagram of steam cracking. As I said earlier, it will undergo the three processes, which are the cracking and quenching, compression, and then at last separation. In cracking and quenching, the feedstock will flow through the furnace and quench column. After that, it will move to the compression section, where it get compressed. So at that place, it will flow through the compression system, and the fourth one is caustic scrubber, and again it will go to the compression system to get compressed, and then at last it will move to the drying unit. After that, the the half produced product will go to the separation process. In it, where you will go for the 6, 7, 8, 9, 10 and 11, which are those parts which were named as cold box, demethanizer column, deethanizer column, C2 splitter, depropanizer column, C3 splitter. Okay, let us discuss the last subtopic in our last slide, which is application and uses of ethylene. So there are various applications and uses for ethylene because, as I said earlier, ethylene is widely used in every side of the world because of its characteristics like saturated compound, saturated hydrocarbon, which it has the double bond, where it can make our work to be easier by reacting with other substance more easily compared to alkanes and other substances. So let us see in which sectors it can help. It can help in chemical sectors, food and beverages, medical and metal fabrication. So in chemicals, as it works as an intermediate for production of plastics. And for the foods and beverages, mixtures of ethylene is used for ripening of fruits. And another thing is to promote the growth of crop because of its reactivity. Another thing is it can also be used in medical field, where it used as an anesthetic, which we will also call in a simple way like drug to lose feeling during the surgery. Usually drug makes people to lose their feelings very quickly and easily, but this drug is mainly purposed for medical reasons, where the doctors will do the operation and any other surgeries for the patient. So this drug is very useful by the production of ethylene for this way. And at last, it also used for metal fabrication. We all know that the ethylene can be easily get burnt because of its high reactivity. So in metal fabrication, it used as oxy-fuel gas for welding, cutting of metals, because it will burn in high temperature. So that's why it used in metal fabrication. So that's it, man. Thank you.